How to perfectly override a dict. How can I make as perfect a subclass of dict as possible? The end goal is to have a simple dict in which the keys are lowercase. It would seem that there should be some tiny set of primitives I can override to make this work, but according to all my research and attempts it seems like this isn't the case. If I override _getItem_//set_item_, then get/set don't work. How can I make them work? Surely I don't need to implement them individually. Am I preventing pickling from working, and do I need to implement _setState_, etc.? Do I need repr, update and _init_? Should I just use mutable mapping? It seems one shouldn't use userdict. Or dict mixin? If so, how? The docs aren't exactly enlightening. Here is my first go at it. Get doesn't work and no doubt there are many other minor problems.
You can write an object that behaves like a dict quite easily with ABCs, abstract base classes, from the collections.abc module. It even tells you if you missed a method, so below is the minimal version that shuts the ABC up. You get a few free methods from the ABC. I wouldn't subclass dict, or other built-ins, directly. It often makes no sense, because what you actually want to do is implement the interface of a dict. And that is exactly what ABCs are for.
How can I make as perfect a subclass of dict as possible? The end goal is to have a simple dict in which the keys are lowercase. If I override _getItem_/_set_item_, then get/set don't work. How do I make them work? Surely I don't need to implement them individually? Am I preventing pickling from working, and do I need to implement _setState_, etc.? Do I need repr, update and _init_? Should I just use mutable mapping? It seems one shouldn't use userdict or dict mixin? If so, how? The docs aren't exactly enlightening. The accepted answer would be my first approach, but since it has some issues, and since no one has addressed the alternative, actually subclassing a dict, I'm going to do that here. What's wrong with the accepted answer? This seems like a rather simple request to me. How can I make as perfect a subclass of dict as possible? The end goal is to have a simple dict in which the keys are lowercase. The accepted answer doesn't actually subclass dict, and a test for this fails. Ideally, any type checking code would be testing for the interface we expect, or an abstract base class, but if our data objects are being passed into functions that are testing for dict, and we can't fix those functions, this code will fail. Other quibbles one might make. The accepted answer is also missing the class method, fromKeys. The accepted answer also has a redundant _dict_, therefore taking up more space in memory. Actually subclassing dict. We can reuse the dict methods through inheritance. All we need to do is create an interface layer that ensures keys are passed into the dict in lowercase form if they are strings. If I override _getItem _/_set_item_, then get/set don't work. How do I make them work? Surely I don't need to implement them individually? Well, implementing them each individually is the downside to this approach and the upside to using mutable mapping. See the accepted answer, but it's really not that much more work. First, let's factor out the difference between Python 2 and 3, create a singleton, _raise key error, to make sure we know if we actually get an argument to dict.pop, and create a function to ensure our string keys are lowercase. Now we implement. I'm using super with the full arguments so that this code works for Python 2 and 3. We use an almost boilerplate approach for any method or special method that references a key, but otherwise, by inheritance, we get methods, len, clear, items, keys, popitem, and values for free. While this required some careful thought to get right, it is trivial to see that this works. Note that ASCII was deprecated in Python 2, removed in Python 3. Here's some usage. Am I preventing pickling from working, and do I need to implement _setState_ etc.? Pickling. And the dict subclass pickles just fine. _repr_. Do I need repr, update and _init_? We defined update and _init_, but you have a beautiful _repr_ by default. However, it's good to write a _repr_ to improve the debuggability of your code. The ideal test is eval repr ==. If it's easy to do for your code, I strongly recommend it. You see, it's exactly what we need to recreate an equivalent object. This is something that might show up in our logs or in backtraces. Conclusion. Should I just use mutable mapping? It seems one shouldn't use userdict or dict mixin? If so, how? The docs aren't exactly enlightening. Yeah, these are a few more lines of code, but they're intended to be comprehensive. My first inclination would be to use the accepted answer. And if there were issues with it, I'd then look at my answer, as it's a little more complicated, and there's no ABC to help me get my interface right. Premature optimization is going for greater complexity in search of performance. Mutable mapping is simpler, so it gets an immediate edge, all else being equal. Nevertheless, to lay out all the differences, let's compare and contrast. I should add that there was a push to put a similar dictionary into the collections module, but it was rejected. You should probably just do this instead. It should be far more easily debuggable. Compare and contrast. There are 6 interface functions implemented with the mutable mapping, which is missing from keys, and 11 with the dict subclass. I don't need to implement _eta_ or _len_, but instead I have to implement get, set default, pop, update, copy, _contains _ and from keys, but these are fairly trivial, since I can use inheritance for most of those implementations. The mutable mapping implements some things in Python that dict implements in C, so I would expect a dict subclass to be more performant in some cases. We get a free _eq_ in both approaches, both of which assume equality only if another dict is all lowercase, but again, I think the dict subclass will compare more quickly. Summary. Subclassing mutable mapping is simpler with fewer opportunities for bugs, but slower, takes more memory, see redundant dict, and fails, isinstance x, dict. Subclassing dict is faster, uses less memory, and passes, isinstance x, dict, but it has greater complexity to implement. Which is more perfect? That depends on your definition of perfect.
After trying out both of the top 2 suggestions, I've settled on a shady-looking middle route for Python 2.7. Maybe 3 is saner, but for me. Which I really hate, but seems to fit my needs, which are: can override my _dict. If you inherit from dict, this bypasses your code. Try it out. This makes number 2 unacceptable for me at all times, as this is quite common in Python code. Masquerades as, isinstance my _dict, rules out mutable mapping alone, so number 1 is not enough. I heartily recommend number 1 if you don't need this, it's simple and predictable. Fully controllable behavior. So I cannot inherit from dict. If you need to tell yourself apart from others, personally I use something like this, though I'd recommend better names. As long as you only need to recognize yourself internally, this way it's harder to accidentally call _m_i_me due to Python's name munging. This is renamed to _midict _m_i_me from anything calling outside this class. Slightly more private than _ methods, both in practice and culturally. So far I have no complaints, aside from the seriously shady looking _class _override. I'd be thrilled to hear of any problems that others encounter with this though, I don't fully understand the consequences. But so far I've had no problems whatsoever. And this allowed me to migrate a lot of middling quality code in lots of locations without needing any changes. As evidence, this URL. Basically, copy the current number 2 option, add print method _name lines to every method, and then try this and watch the output. You'll see similar behavior for other scenarios. Say your fake dict is a wrapper around some other data type, so there's no reasonable way to store the data in the backing dict, your _dict will be empty, regardless of what every other method does. This works correctly for mutable mapping, but as soon as you inherit from dict it becomes uncontrollable. Edit, as an update. This has been running without a single issue for almost 2 years now, on several 100,000, might be a couple million, lines of complicated, legacy written Python. So I'm pretty happy with it. Smile. Edit 2, apparently I miscopied this or something long ago. At class method _class_ does not work for isinstance checks, at property _class_ does, this URL.
All you will have to do is or a sample usage for my personal use. Note: tested only in Python 3.
If you want to see more, please consider subscribing.